Space is filled with some truly bizarre objects: black holes, neutron stars, pulsars, all mind-bending phenomena that exist far beyond our solar system. But perhaps one of the rarest and most mysterious cosmic giants is something we don't often hear about: the quasi-star. These monstrous, hypothetical stars are unlike anything in our known universe. They're thought to have existed only in the early universe and are unimaginably massive, with cores that might contain black holes themselves. In other words, quasi-stars are cosmic behemoths of almost incomprehensible scale and power. But what if, by some bizarre twist of fate, one of these ancient quasi-stars wandered into our solar system? What kind of impact would it have on our planets? Could Earth survive its arrival? And what would we see as it moved through our cosmic neighborhood? Today, we're diving into this extreme scenario to understand what would happen if one of the universe's rarest giants entered our solar system. Strap in as we explore this journey into astronomical destruction. First, let's start with the basics. What exactly is a quasi-star? To imagine a quasi-star, picture something 100 times the mass of our Sun and hundreds of thousands of times more luminous. While no quasi-stars exist today, scientists theorize that they might have formed in the early universe when massive clouds of gas collapsed under gravity, creating stars with internal pressures so intense that they sparked the formation of black holes at their centers. Unlike ordinary stars, a quasi-star is sustained by the constant feeding of this central black hole. As the black hole consumes surrounding matter, it generates enormous amounts of radiation and energy, preventing the quasi-star from collapsing completely. The result? A massive, unstable star glowing with intense luminosity, dwarfing almost anything we know in our current universe. Quasi-stars are short-lived, burning out in just a few million years due to their immense size and power. But for those millions of years, these cosmic titans are among the most powerful objects in the universe. So, what would happen if one of these giants somehow entered our solar system? If a quasi-star approached our solar system, we'd first notice its arrival in the outer reaches, around the Kuiper Belt. Even from this vast distance, its gravitational impact would be catastrophic. The Kuiper Belt, a ring of icy bodies, dwarf planets, and comets beyond Neptune, would become completely destabilized. Its objects, normally held in place by the Sun's gravity, would be hurled in all directions. Some Kuiper Belt objects would be flung into deep space, while others could be pulled into the inner solar system. This influx of debris would trigger an intense period of comet and asteroid impacts on the inner planets, including Earth. We'd experience a terrifying cascade of celestial objects streaking across the night sky as the quasi-star's gravity disturbed the delicate balance of our solar system. But that's just the beginning. As the quasi-star continued its journey toward the inner planets, the effects would intensify. Let's take a closer look at what would happen as it moved closer to the gas giants, beginning with Neptune and Uranus. Once the quasi-star reached the orbit of Neptune, its immense gravitational pull would start wreaking havoc on the solar system's largest planets. Neptune and Uranus, which orbit the Sun at great distances, would be the first to feel the quasi-star's influence. These gas giants might be ripped out of their orbits or even drawn directly toward the quasi-star's overwhelming gravity. The tidal forces alone could distort their shapes, stretching them into elongated forms before potentially tearing them apart. As a result, massive fragments of these planets could be pulled toward the quasi-star, creating a surreal and catastrophic spectacle. The destruction of Neptune and Uranus would not only alter the structure of our solar system, but would also send additional debris hurtling inward toward the Sun, and potentially toward Earth. But the quasi-star's journey would continue, pulling it even closer to our inner planets. And as it approached Jupiter and Saturn, the consequences would become even more devastating. As the quasi-star approached Jupiter, the effects would reach another level. Jupiter is the largest planet in our solar system, with a powerful gravitational field that influences the orbits of its moons and even some asteroids. But a quasi-star's gravity is on an entirely different scale. Jupiter's massive storms, like the Great Red Spot, would pale in comparison to the gravitational forces at play. The quasi-star could very well strip away Jupiter's atmosphere, tearing apart its dense gas layers and potentially shattering the planet's core. Saturn, with its beautiful rings, wouldn't fare any better. The quasi-star's tidal forces could shred Saturn's rings, scattering icy and rocky particles across space. In the process, Saturn itself might be pulled apart or thrown out of its orbit. If Jupiter and Saturn were disrupted or even destroyed, the gravitational balance of our solar system would be permanently altered. For Earth, the consequences of this chaos would be catastrophic. The quasi-star would continue to destabilize everything in its path, and it was only a matter of time before it reached the inner planets. Now, let's consider what would happen as the quasi-star moved past Mars and toward the inner solar system. By this point, Earth would already be experiencing dramatic changes. Our planet's orbit would become increasingly erratic as it was pulled by the quasi-star's gravity. This irregular orbit would disrupt Earth's climate, leading to sudden temperature shifts, catastrophic weather events, and violent tectonic activity. And then there's the light and radiation. A quasi-star emits far more radiation than our Sun. As it neared Earth, our atmosphere would be bombarded with deadly levels of radiation, stripping away the ozone layer and exposing life on Earth to intense cosmic rays. Our atmosphere would gradually erode, and the oceans would start to evaporate under the quasi-star's blistering heat. Temperatures would rise to levels no life could survive, transforming Earth into a scorched, lifeless rock. The quasi-star's gravitational pull could even tear Earth apart. If the tidal forces became too strong, Earth could break into pieces, scattering its fragments across space. For humanity and all life on Earth, survival would be impossible. But what about the Sun? After all, our Sun is the anchor of the solar system. Could it withstand the presence of a quasi-star? As the quasi-star neared the Sun, the two massive bodies would exert intense gravitational forces on each other, creating chaotic tidal waves of energy. The quasi-star might start pulling material away from the Sun, drawing streams of superheated plasma and gas into space. This interaction could destabilize the Sun itself, causing violent solar flares and coronal mass ejections that would add even more radiation to the solar system. Eventually, the quasi-star might consume the Sun, adding its mass and energy to the already immense quasi-star and transforming the solar system into a cosmic furnace. Or, in a different scenario, the quasi-star and the Sun might merge, creating an even more massive black hole at the center of what was once our solar system. Either way, the result would be complete annihilation of everything within the solar system. There would be no planets, no asteroid belts, no signs of life or civilization. Only the quasi-star or a black hole, an eerie remnant of the destruction it left behind. So, what would happen if a quasi-star entered our solar system? The short answer: nothing would survive. Our planets would be torn apart or thrown into deep space. the sun itself would be destabilized or consumed, and every trace of Earth's life and history would be erased in an instant. It's a sobering reminder of the incredible forces that exist in the universe and of how small and fragile our solar system truly is. Fortunately, quasi-stars are only theoretical objects that likely existed in the early universe, far from our current timeline. The chances of one ever wandering into our solar system are astronomically low. But thinking about it, about the sheer, incomprehensible scale of cosmic power, can inspire a new appreciation for our stable, relatively peaceful solar system.